In today's lesson, we are going to start learning about the basics of the atom. The diagram of the atom that you see here is going to be more complex than we're going to learn in physical science. This is almost more of the Jimmy Neutron style of the atom, if you will, where we show the electrons in these loops. And here we're generally going to see what we call the Bohr model of the atom, which is where you see the nucleus surrounded by those rings of the electrons. If you're watching this video lesson, chances are you are doing this at home and you don't have your desk available. So I've included this copy of the periodic table for you. This is something that you will need for the next 2 units as we work our way through chemistry. If you are at home, if you go onto my Moodle page at the very top, like before any of the unit folders even, there is something that says complete periodic table handout, probably with number line. If you open that up, it will have this on there, and then it will also have a second page. You're going to be referencing that quite a bit as we work through these lessons and as you work through the homework. So let's actually start learning a little bit about the atom. So here we have our 3 subatomic particles. Sub meaning, like smaller than, atomic meaning atom. So smaller than the atom is going to be our electron, our proton, and our neutron. When we talk about the size of these, it's very important that we know that the electron is going to be the smallest. We also have our proton, and you don't need to know like necessarily the relative or the real size of these, but the proton and the neutron are going to be the same size as one another. So both these are going to be the larger of the particles. And so I'm just going to type this in there because otherwise my handwriting is terrible. But these ones are going to be both the same size as one another. Biggest thing is that you know the electron is the smallest. Then for their charge, the electron has a negative charge. The proton, and easiest way to remember this, proton positive. So the proton has a positive charge. And then our neutron, the neutron has a neutral charge. Or you could also say that it has no charge, if you will. But generally we'll say it is a neutral charge. So neutron is neutral, proton is positive, and then the electron's negative. And then their location for these, and if we look at the picture of the atom, which is, you have your nucleus in the center, then you have the rings that surround it. So these rings are what we call the electron cloud. And sorry, my handwriting is terrible, that's why I typed the other stuff. So that's our electron cloud, and then here in the center of the atom is our nucleus. So the nucleus is where the protons and neutrons lie. And then the electrons, believe it or not, lie in the electron cloud that surrounds the outside. Now what I would like you to do is take about 15-30 seconds, pause the video, and try and come up with any patterns that you might notice in these numbers. Alright, now that you've had some time to look at these numbers, hopefully there's a couple patterns that you noticed. One is that your atomic number is always equal to your number of protons. Those are always going to be the same no matter what. Another observation that you may have noticed is that your number of protons plus your number of neutrons is going to be equal to your mass number. So protons plus neutrons is equal to your mass number. And one other observation you might notice right now is that, and this is only going to last for the next couple days, next couple lessons, but for now we are going to say our protons and our electrons are equal. And the reason for that is when we talk about an atom, all atoms want to be neutrally balanced. Because remember, your protons have a positive charge, your electrons, have a negative charge. So what those charges do is they actually balance each other out and they make the atom neutral. Because that's when atoms are stable. So for the next couple days, until we start talking about ions, we're always going to assume our protons and our electrons are equal. And now here's a few different things that we know about the atom. One is that atomic number is equal to the number of protons in an element. Atoms are going to be electrically neutral. That is when they have no charge, so that's when your number of protons and your number of electrons, and your number of electrons are the same. So when your protons and electrons are equal, that means that your atom is balanced. And the way I like to look at this is, since protons are positively charged, I like to think of those as being +6. Electrons are negatively charged, so I think of that as -6. Well, guess what? That gives us an overall charge of 0, so therefore it's neutrally charged. Your mass number, which has units of AMUs, or atomic mass units, so atomic mass has units of atomic mass unit, probably the most creative name ever. Well, your mass number now is equal to your protons plus your number of neutrons. And one thing to keep in mind, and we'll talk more about this tomorrow, is mass number is not the same as average atomic mass. You cannot look at the periodic table for a mass number. Because that is going to throw you off. So your periodic table shows you average atomic mass. It does not show you a mass number. And we'll take a look here at what mass numbers are coming up here. So this slide again is just reinforcing that the electron is much, much smaller than the proton. So it takes about the mass of 1,836 electrons to equal the mass of one proton. So again, electrons are much smaller than the proton. And then your neutron and proton, we say, are about the same mass. Here's a little bit bigger picture of an atom, just to give you a visual. So in the center here again, we have what we call the nucleus. And your nucleus is where your protons and neutrons lie. And then outside, circling around it, is your electron cloud, which is where your electrons spend their time. As it turns out, there are actually smaller particles making up the proton, neutron, and electron called quarks. We're not going to spend much time on them, but just to make you aware that there are even smaller particles out there. But we're not going to spend time on them. Biggest thing you need to know is protons, neutrons, and electrons. Here's an example. If you go back and look at that periodic table that I mentioned on the second slide, this is what it'll look like. So in the upper left corner here, we have the atomic number, or the number of protons. Now this is one of the key parts of reading the periodic table. The definition of a beryllium atom is an atom that has 4 protons. So if you're ever given a problem and it says 4 protons, automatically that element is beryllium, because any atom with 4 protons is beryllium. I don't know if I can state that anymore. Or if you go back and you look at the periodic table and you look at, say, carbon. Well, the definition of carbon is any atom that has 6 protons. So your number of protons will always tell you what element you have. The Be is what we call our symbol for that element. In this case, the element's name is beryllium, but a lot of times we'll shorten and just write Be. And then here is the average atomic mass. Now remember, mass number is equal to protons plus neutrons. Well, guess what? I can't have fractions of a proton. I can't have fractions of a neutron. So I could have berylliums and every beryllium is going to have 4 protons. We said that earlier. So if I have a beryllium with a mass of, say, 9, so I have beryllium 9, well, that would mean it has 4 protons and 5 neutrons. But there might be some other berylliums out there. There might be berylliums that have 4 protons and 6 neutrons. But notice, if I do this, my mass number is either a mass of 9, a mass of 10. So this right here is an average atomic mass. It is the average of all the beryllium atoms. And again, we'll talk more about that tomorrow. But biggest thing I want you to take away from this is not equal to an atom's mass number. Never look at the periodic table. Never look at the periodic table when you're trying to find a mass number. Alright, so let's get a little bit more practice on these tables, because these tables, you're going to see them quite a bit. And they're kind of like solving a puzzle. So we have a few different clues that we're going to use to solve for these. One clue is that mass number, and I shorten number by writing the pound sign or the hashtag sign or whatever you want to call it. So that mass number is now equal to our protons plus our neutrons. So that's one clue that we have. And I'm going to label that as clue number 1. Okay? A second clue that we have is that, and we said this was true for the next couple days, our number of protons is equal to our number of electrons. But again, this is only for the next couple days, but for now this will help for solving them. And then our third clue that we're going to use is that come on, keyboard. The third clue is going to be that our atomic number is equal to our number of protons. And then we could add a fourth clue here, I guess, and say that our fourth clue is that our protons, so our number of protons determines our element. So using these 4 clues, we're going to go through and solve some of these tables, and we'll use these clues on the next slide as well. So here it is telling me, and this is a puzzle, so this is like solving a Sudoku problem where they give you a bunch of numbers and you solve for the rest of them. So here if I have this atomic number of 4, well, if I look at my clues, oh hey, my atomic number is equal to my number of protons. So I can fill in my number of protons. Then we look for some more clues. Okay, well now I have protons, neutrons. Oh hey, my protons plus my neutrons is equal to my mass number. Okay, so that means my mass number here is 9. Well, let's see, I still need to solve for electrons. Oh hey, look, electrons is equal to our number of protons. So therefore, I have 4 electrons, and now I look at the name. Well, since I know, and we're going to use our last clue, my number of protons tells me my element. Well, any atom that has 4 protons is going to be beryllium. So therefore, the element name is Be. And now let's do the bottom row. So the clues are a little bit different this time, or at least the order we're going to do them in. Alright, so I have a number of electrons and I have a mass number. Well, I know that my number of electrons is equal to my number of protons. So I'm going to fill that in. Oh, I don't want to write P there. So my number of electrons, so that means I have 4 protons. Now my mass number is equal to my protons plus my neutrons. Ooh, we need to do a little bit of algebra. So we have this equation over here that says mass number equals P plus N. Well, I'm just going to plug in my numbers. Mass number of 10 is equal to, and I have my number of protons of 4, plus, well, I'm going to solve for my variable N. So I'm going to subtract 4 from this side, subtract 4 from this side, and we are left with 6 is equal to N. Perfect. So that means I have 6 neutrons. Well, I also have this other hint. Okay, number of protons was 4. My protons is equal to my atomic number, so therefore my atomic number is 4. And again, I have 4 protons. My protons tell me my element, so my element is Be. Ooh. Well, this looks a little confusing. If I have beryllium, shouldn't that mean that all these numbers are the same? Well, not necessarily, because you can have a beryllium. You can have beryllium that's going to have, and they're all going to have 4 protons, so I'm just going to draw protons as blue dots. And then some of them are going to have 5 neutrons, which I'm going to draw as the black dots, and some are going to have 6 neutrons. So they're still all beryllium atoms because each one is going to have 4 protons in its nucleus, but some have 5 neutrons, some have 6 neutrons. It's still beryllium atom, but they just have different numbers of neutrons. So now let's continue on to the next slide and try solving for that problem. Alright, so we're going to use the same clues from last time, and I'm just going to go copy and paste them over here quick. Alright, so if we go through and start solving for this one, automatically I'm just going to go through and do my atomic number is equal to my number of protons. I'm just going to do that for all of them, because that's going to hold true no matter what, that these 2 columns are going to be equal. And looks like these 2 down here, we're actually going to have to do a little bit of solving for those. So we'll come back to those ones. For this first one now, okay, well, mass number I know is equal to protons plus neutrons, so I'm going to add those columns together and get 14. We also have our hint here that our number of protons and electrons is equal. So therefore, my number of protons is equal to my number of electrons, so we're going to get 7 there. And then looking at the periodic table, element number 7 is going to be nitrogen, so we're going to write nitrogen in as our name. If we go through and solve the second one, well, again, now we're given our mass number. So we have a mass number of 40. We have our number of protons. Well, remember, mass number is protons plus neutrons. So whatever amount of them is not coming from my protons must be neutrons. So therefore, I'm going to take 40 minus 19, and that'll give me an answer of 21. So now if I added my protons and neutrons together, 19 plus 21, hey, look at that. That gives me our mass number of 40. Protons and electrons were the same, so that means I have 19 protons, 19 electrons. And if we look at our number of protons on the periodic table, element 19 is going to be potassium. So we're going to write potassium in here. And now I would like you to please pause the video and try solving for the rest of them on your own. Alright, now that you have tried these on your own, let's continue solving for them. So here, again, we have 23 minus 11. That's going to give us our number of neutrons of 12. Protons and electrons are the same, so I'm going to have 11 electrons there. And our element with 11 protons is going to be sodium. So we're going to write Na in there. And then we look at the next one. So we're going to have to solve this one a little bit different. I still know mass number is protons plus neutrons. Since I have 10 neutrons, well, the rest of those must be protons. So I have 10 protons, which means I have 10 electrons in this case, and an atomic number of 10. And then looking at our periodic table, element number 10 is going to be neon. And now this next one's usually a little bit trickier for people, because this one doesn't give us any of our protons. It gives us neutrons, I guess, doesn't give us electrons. So what we actually have to do is work kind of backwards. You go through and you look at your periodic table and you look at carbon and you see, oh, well, carbon has 6 protons because it's element number 6. That's its atomic number. So since that has 6 protons, that means atomic number is 6, and that also means its number of electrons is 6. And now we take our, we need to solve for mass number, which is protons plus neutrons, so we take our 6 plus our 7, and we see we have a mass number of 13. And now we're going to look at one it's a little bit higher up on the periodic table. So 56 electrons means 56 protons, means atomic number 56. And so element number 56, looking at our periodic table, is barium. And then again, we solve for a mass number. We take 56 plus 81, and we get a mass number of 137. And then looking at our last one, atomic number 1, well, that's the first element. That's going to be hydrogen. That means it has 1 electron. And now students get kind of confused in this one. Our mass numbers are protons plus neutrons. So our number of protons is 1. Well, guess what? That means our neutrons are 0. And it's true, most hydrogens don't have any neutrons. So there we go. Hopefully that is a good start to you being able to solve for kind of the basics of the atom, our protons, neutrons, and electrons, how mass number works, and then kind of an introduction to the periodic table.